afternoon. Welcome to the final session down here in this room of the DSF Oktoberfest 2023. Just to remind you that there will be networking down in the space bar after this. Take your free mug for a beer. And also we'll be announcing the competition winners upstairs in control at the end of the afternoon. So, to get everyone where they need to be on time, it's my great pleasure to be able to introduce Lydia Monnington from Stuart. She's going to be talking about advanced SQL, top tips for dealing with real-world data. She's head of analytics at Stuart, the transport logistics courier company, and she identifies the most important challenges for the company's business and designs data-driven solutions. That's included identifying delivery cost drivers, recommending expansion opportunities, and she also thinks that charities deserve the same opportunities to use data science as businesses, and she's one of the directors of the STEMettes, who help girls, young women and non-binary young people into STEM subjects, and she's also on the scoping committee for DataKind, who help charities, local governments and social enterprises with data science. So straight over to Lydia.
Thank you very much. So, as experienced data practitioners, I'm sure you're all aware that you always get to work with perfect data with no errors or mistakes. Yeah, me neither. So who's ready today to get some better results from the real-world data you have? I'm going to talk about three main things. The first is joining on messy data. The idea is to give a relatively straightforward example that allows you to think about how to avoid errors and then correct errors when you find them. Secondly, I'm going to talk about arrays. They're becoming more common when you're working with the biggest data sets, but they can be really clunky to work with if you don't know the right functions, so I'm going to give you a couple of tips for working with arrays. And finally, window functions, starting with two straightforward examples to get used to window functions if you've not used them before, and finally a longer example using lag to generate sessions, unique session IDs from website visitor logs. So, a little bit about me. I'm head of analytics at Stuart. You've probably not heard of us unless you work for one of our competitors, but we do last mile delivery, and you've probably used us if you've ordered a takeaway delivery, or if you've ordered a 1-hour grocery delivery, so you get it in quickly. That would almost be quite often be delivered by a Stuart courier. But we do it direct to business rather than to consumers, so you probably haven't heard our name. I've used SQL and different versions of SQL at 4 different companies, Ocado, Meta, GHG, Set and Stuart. And yes, I've even got to use graph databases, but we will not be talking about those today. At first, when I was a teenager, I first used SQL when designing a website, and I found it really hard to actually understand the intricacies of how SQL worked, especially joins. But I realized I'd got it down when I did my Facebook interview, and the hardest part was writing the word select on a whiteboard. If you ever tried to code on a whiteboard, you will appreciate this challenge. So, how to get the most from this session? There's some relatively in-depth technical examples. If I go a little bit fast, or if it's a bit advanced for you, feel free to sit and absorb. The slides will be available after the talk, and there'll be a recording, so you don't worry about catching up. If you do want to do it live, there are some links at the bottom of the page. I realize, having seen the room, that finding the links at the bottom might be slightly harder to get, so I recommend going to the Data Science Festival page for this talk, and then in there at the bottom there's a little link which says handouts, and that will have all the links, so you don't have to type them all. Just let people take a couple of photos. There's also quite a lot going on some of the slides. So what I've done is I've done highlighting to make it easier to see what's going on at any given point. If I've changed the code in a small way versus the previous slide, that's usually highlighted in blue. And if the data's changed in a small way, that's also highlighted in blue. If there's an error, or something that you should pay attention to that's not quite right in either the data or the code, that's in red. And if there's a particular feature I want you to pay attention to, usually one thing relates to another, then I've done that in green to kind of make it easier to find. So in general, TLDR, if it's different color, pay attention. Final quick note on versions of SQL. Different versions of SQL are different. Obviously, most of SQL has a standard, but different versions implement certain functions slightly different ways. And so, especially in the array example, it might not quite work for your version. If you're copying this and you're trying to find it, just search for the function in the version of your SQL you're using, and usually there will be an equivalent function, or if not, a workaround for either easy or bad. So, firstly, joining on messy data. The reason I think this is really important is because when joining on messy data, the risk is you make a mistake, but it's not visible to you until you've done your results, you've shared it, you've presented it to stakeholders or your boss, and they say, why did this number, higher than total sales for the company, even though you're showing sales for one department, and you realize you've done something wrong. So in the real world, data is messy. You'd love for it to be like this on the left, perfect data, you know how to join it, you know what the unique ID is, there's never any duplicates, but the reality is rarely like that. You have duplicates, you have things where you don't know how to join them, you have things that, maybe you have to do a regex to get a postcode out of something, all of that fun. And the risk with that is that things can go wrong and you don't notice them. So what I'm going to do is take you through a relatively simple example and show how I'd detect the error, how I'd avoid it when writing a future query, and then if I'd found an error, how to address it and resolve it so it can't reoccur. So the first example I'm going to give is you want to calculate customer order value. So you've got a table called sales, where you've got two order IDs, A333 and A666, and you've got the products they've built. So each row of what you're buying is one product ID. You've then got a product details table, which has product ID and price. And so what we want to get out is the order ID and the order value. So for A333, they've ordered one of each product. 5 plus 2 plus 3 is £10. A666, they've ordered just product 2, which is £2. As you probably know, this is a relatively straightforward piece of SQL, assuming your data is good. So you just need to select from sales inner join product details on product ID, which is our ID, and select order ID, sum of price as order value, and grouping by 1. So that's nice. But let's introduce a little error in our data. We've somehow now got two different rows for product details. We've got the original row with the price of £3, and we've got a new row of price of £3.10. And our order value for the first order is now really wrong. It's gone up £3.10. So what's happened here? The first thing I always do is if I'm worried there's something wrong with my code, the thing that I find to be true is that doing a join followed by a group by hides any errors. You can't detect them as easily because you can't see you've got a duplicate row. If you take out the group by and just do the select, you then get the two rows in your output, and it's much easier to see what's gone wrong. So why are we getting a duplicate row here? I'm going to give you a little bit of an intuition about how SQL joins work and how I think about them. So the way I think about it is you're taking sales, you're joining onto product details, and effectively what you're doing is you're going through every row in the sales table, going through all the rows in product details, finding all the matches based on your on condition, and looking for the match. So here, the first row, product 10100101, we check for it, there's one match, it returns one output. For row 2, it's the same, you return one row in the output. Row 3, where we have our error, we find two matches, and this then duplicates all the information in the sales table, so you get two rows in the output. And that's where the error comes from. And then finally, order A666 has only product 2, which is there, and we get one row in the output. So how do we avoid making this error? This sort of error is really risky because you can't detect it. If you just looked at this table on the right and you hadn't seen the correct table, you wouldn't know that there was anything wrong. It looks perfectly fine. So how do you identify it? There's two things I always recommend to make sure you identify duplicates and avoid issues like this. The first is sense checking. This is mostly the way that stakeholders will find you out if you've made an error, because they are comparing your numbers to other dashboards, other reports, and they know that the average order value is actually £6, and the fact you're saying it is £7.55 means something's gone wrong. The second thing you can do is check your tables for duplicates. And you can do this either before you, like on the output of your query, or on all the input tables. Both work. And the second thing you can do is look at your input tables, see if they're set up to prevent duplicates. So is the DBT model got a check, things like that. There's two SQL kind of sections of code I like to use for checking for duplicates. The first one I like kind of if you want to look at the output of your query without really changing it, or if you want to like add in something you're grouping by, like a category, to see if it's a particular region or something like that that's got the error. Effectively, what you're doing is counting one, which will give you one row for each row in the table, and count distinct, so that's the number of distinct product IDs. If that number is the same, you don't have any duplicates. If the number is different, you do. The second query is slightly different, and I use this in general to return duplicate IDs, example IDs that have problems, and to like use them for debugging. You know, if you give 10 examples to your data engineer friend or your engineer friend to say, like, there's something wrong here, can we debug it? Having some really tangible examples makes that a lot easier. So here we're doing select product ID and count one as appearances. That's how many rows it appears in the table. From product details, grouping by one. And you're saying count one is greater than one. So that means you have more than one appearance in the table. So you found a bug, you know something's wrong with your code. How are you going to fix it? This is kind of the flowchart, and then I'm going to go in a little bit more detail on each of these suggestions. The first question is, why does the duplicate exist? Is it something true about the representation of the data? Like, have you used the table wrong, something like that? Or is it a bug? And what you do depends on those two questions. So if it's a true representation of the data, are you using your query correctly? Have you missed a filter? Have you missed something else in how to use it? And can you fix it really easily? The other option is to use a subquery as a workaround to fix it. If it's actually a bug, in the short term, you can use a subquery to work around it, but it's not a great solution. It'll slow down your code. You're not actually fixing the root cause. So in the long term, you want to work with data engineers to solve the problem. So finding and fixing the root cause and adding uniqueness checks. So a little bit more on each of those three options. If you want to fix your query to use the correct data model, let's say we're in the same example, but we hadn't looked at all the columns. And when you look at all the columns, you realize you've got start date and end date, and you've got a column called active row equals true. So here, when you look at the data, you realize that actually the price changed on October the 1st, and so now there's a new price. And that's actually completely correct. And a lovely kind person has also added a flag where active row equals true. And so all you need to do is add that single row of code, line of code into your query, and then you won't have any more duplicates in your data. And that's, in a way, this is the best possible scenario. You just didn't know something that you needed to know. The second option is working around the issue with a subquery. You can always do this. It's relatively straightforward to do, but it makes your code a lot longer, and it makes it run slower. So it's not a great long-term solution, but if you just want a quick, hacky fix, this is a great way of doing it. So what we're doing here is we're creating a common table expression, unique product details, and the idea behind this is you are forcing that product ID to be unique. So the fact we're doing select and then just group buying only product ID means it has to be unique. And we here are taking max of price as the price to get one of the values of price. Now, when you were looking at that last query, you might be thinking, why did she pick max? Is that the right value? And you're quite right. You don't really know what the right value to choose here, and this is one of the disadvantages of this method. It could be the max, it could be the min. If you're feeling bold, you could take the average, or if you're feeling risky, you could use any, which picks one at random. So yeah, but you have to know something about the data to know the correct one to choose, unless you're just happy to say approximately right is okay, which in some circumstances is fine, but not in every case. And then we've used this common table expression in the bottom of the query just to replace product details. So option 3 is fixing the bug to stop it happening again. The first step is finding the root cause of the bug. I'm not going to go into debugging SQL right now, because I don't think we really have enough time, but finding the root cause of the bug and resolving that. And then what you can do is add uniqueness checks to your models, for example, in DBT or code, to make sure this can't be happen again without finding it. So in DBT, You just need to add the name of the model, the name of the ID, and test equals unique, which is a really simple function. Cool. On to arrays. Who here has used arrays in SQL before? Wow, OK, quite a small number. So why do we use arrays? In general, in SQL, data is stored in normalized schemas. You have every level of aggregation, every unique thing you're storing has its own table. It's stored like that. There's a lot of really good reasons to use normalized data. The most common, easy to describe example is avoiding duplicated data. Here, where we've got it all in one table, you've got order ID and product ID, and then you've got the product name yogurt repeated for every single time someone's ordered it. If we wanted to update the yogurt, let's say it changed name to Greek yogurt, you'd have to update it in potentially thousands or even millions of places. And if something goes wrong with that update, when you're then querying it, you'd have the same product with 2 different names, and you wouldn't know which one to use. So that's really not a great experience. So in general, we normalize data to have one row, and we do the join. But you probably can see quite clearly that normalized data requires more joins to query. In the first case, if we wanted to query number of sales of dairy products, it's a really simple query. We're just counting one from orders where category equals dairy. Really nice, simple query. Couldn't really be simpler. But if we want to do it with the normalized data, we need to select from orders, in a join onto products, with all the risks we just talked about, on product ID. So in some cases, the join is so expensive that effectively you can't do it, or doesn't make sense to do it in the database system. This usually happens when you have really, really huge data sets, so in billions or hundreds of billions of rows, where most of the database systems effectively can't do joins, or not in a reasonable amount of time. I'm not going to talk in depth about how to structure data. If we want to do that next time, Data Science Festival, I can recommend some good data engineers. But suffice to say, in some cases, we want to have one big table rather than a lot of smaller ones. So arrays effectively allow us to use one big table, but without always creating new rows. So in this example, we've got 3 products, milk, yogurt, and granola, and we've got a product granularity table, so each row is one product. But we might want to have allergens in there. One way would to be create a new row for each allergen, but then if you're querying on number of products, that's going to make your life a lot harder. So instead of having new rows for each allergen, you can store them in an array. In a similar way, you can use maps and structs to store key-value pairs. I wouldn't recommend doing exactly what I've done in this example as good database design, but it effectively allows you to store a key and a value. So here we've got manufactured in the UK, used by for the 17th, for the milk. For the yogurt, the used by is the 25th. And for the granola, it's best before next year, and the brand is Kellogg's. The naive way of querying these is you can access one element at a time. But this, as you can probably tell, is a little bit clunky. Effectively, you can select from the table. So if you want to select the first item from the allergen array, you select allergens and then square brackets 0, because it's counting from 0. And so here you'd return milk and milk for the first 2 rows, and then for the granola you'd return the first one, so that's the oats. In a similar way, if you know that you want the use by out, you can do additional details use by to get the use by date. And for the 2 where we have a use by, it returns them, and for the other row it returns null. So that's one way, but it requires you to know all the keys. It's a little bit hard to get the other items in the array. So luckily, there's a better way. You can use a function called cross-join on nest to pivot arrays into rows. The way this works, and this is a syntax I always find a little bit clunky. You do a cross-join on nest. You then have to put the column name in brackets. So here, allergens. And then you say T, which is the name you want the table to be referred to, and then the name you want the column to have. So here, value. And then you're saying T.value is the allergen you want. So that gives your output where you split the allergens into new rows. So if you wanted to work with them, you then can, as you would with any other SQL. The next thing you can do is the same for maps and structs. So here, you're again using cross-join on nest. You're again putting the column name in brackets. And here you're putting T and then key and value to give it the 2 things that you want out. You can then refer to them individually, or you can return both to get the output effectively unpivoted. And you can then, again, work with that as you would any other SQL. So if you're working with arrays, I'm going to give a particular notice about different variants of SQL here, because this really differs. If anyone's following along in the code, you'll see I've had to do something totally different in Postgres for the maps, because they don't work the same way. In Presto, Trino, and BigQuery, you can use cross-join on nest pretty much as I described. In Postgres, you can only use it for arrays. And in Hive and Spark, there's a very similar function called lateral view explode, which does the same thing. So yeah, check your version of SQL and their documentation for what to do. Great. So now we're going to talk about window functions. The first two examples are kind of relatively straightforward to get a sense of how to use window functions and what they can do. And then the third one's more in depth, talking about sessions. So firstly, sum. Let's say, with our same example, if instead of wanting the order value as only 2 rows, one for each order, we wanted a function that was the order value, but we want to keep each row for each product. Maybe we want to see what percentage of the whole order this customer spent on each product, or something like that. You can do this without a window function, but it requires a subquery, and so it's a little bit clunky. So what this looks like is you would run a common table expression, order total, where you're effectively doing what we did in the previous query right at the start, selecting order ID, sum of price as order value, and grouping by order ID. You then join that back into your original table on order ID to get the order total. And that works fine, but it's not the quickest and it's not the easiest to read. With a window function, this is much more simple. Effectively, all you need to do is write sum of price over partition by order ID is order value. I'm going to go through this a little bit, because if you've not seen window functions at all, this looks a little bit odd. The way I think about this is you start looking at what's in the bracket after the word over. So here we're partitioning by order ID. I always think about that as either grouping by or splitting the table into sections based on the thing you've put here, or multiple things you've put here. Here, order ID. And then what it's doing is the function you're telling it to on each section. So here we're saying sum of price over everything in the same section. So here we're looking at the we're looking at the first row. We've got order ID A333. We're looking at the first 3 rows. OK, we're summing across those. So that's 5 plus 2 plus 3. And then that's what you get out. The other thing you can do with this is it doesn't have to be just order ID. You could do order ID and category here. So now we've added a column that shows the total per category rather than the total for the whole order. The other thing you can do with window functions, which I actually only found out this week from one of my colleagues, is you can qualify them. So you have where and you have having for normal where clause and after a group by aggregate. If you're using a window function, you can use qualify to use that as a filter for a window function without having to use a subquery. So, second window function example is moving averages. You've probably all got some graphs that look a little bit like this. Maybe you've got a weak shape. It's maybe a little bit noisy for other reasons. So it's quite hard to see what's going on. A moving average can make this a lot clearer. You're taking it, you're smoothing it out. This can be done in SQL. And this, again, uses a window function, but a slightly different one in a slightly different way. So the way it works is effectively you're saying, we want to average this row, the one above, and get the output out. So the way the code works is you're taking, again, we'll start with where it says over. So first, we're ordering by date. So here, imagine we're taking the whole table and sorting it by date. The next thing we're doing is saying rows between one preceding and current row. What that means is you're looking at your sorted table. You've got your current row. You're going one preceding, so that's one up. And you're taking those two. So you've got 2 rows you're thinking about at any given time. And then on that, you're doing the function. So you're averaging the units sold. So that, as you would expect, averages the 2 units sold. So to give an example, let's say our active row is the 3rd of January. That's currently 150 for units sold. The row 1 preceding is the 2nd of January. So we're taking that. We're averaging those two. 130 plus 150 gives 140. And that's how that works. In general, You probably don't want a 2-day average, you want a 7-day rolling average. The code is basically the same. The one thing I'll flag to you is this is 6 rows proceeding, not 7. I've quite often ended up with an 8-day rolling average because you think you want to type 7 because it's 7 days, but because you're including the current row, it's always one less than you think. Nice, okay. Finally, using lag to generate sessions. So let's say, slightly bigger link because this one's more in-depth. So I'll leave that up just a little bit so you can have the code to have a look at. I'll wait till everyone's put their phone down. Okay. So let's say we've got some website sessions. We have the page view ID, we've got the user ID, we've got the page they visited, and we've got the time they visited. What we want to get out is we want to say a session is any gap of more than 30 minutes between page views, and then we want to create a unique session ID based on that. So we're going to do 3 steps. We're first going to split out by user ID, then identify when a new session starts, and then use that to create a session ID. And in the process, we get to do 2 whole different window functions. So first, we need to get the details of the previous page view. This allows us to use a new window function we haven't used yet. Basically, what we want to do is on the second row, we want to get the details from the first row, so the page view ID and the time of that page view ID. This is what it looks like without a window function. I'm not going to talk through this because it's a nightmare, but please appreciate that this is a greater than symbol, not an equals, and so it's also incredibly inefficient. But if you want to do it without a window function, this would be the way. With a window function, it's much less painful. So I'll talk you briefly through how this works. Again, we'll start with the over. You're partitioning by user ID. So again, imagine we're splitting everything up for each user. You're then ordering by view time. So you're looking at ranking the whole table by the view time. And then we're using a new function called lag. What lag does is it means you go up, or there's also a function called lead, which goes the opposite way, or down the table the number of rows you want. So here we've got our sorted table by user ID. We want to get the page view ID from 1 row up. So that's what the 1 here means. So this gives us the output we described. We've gone 1 row up and pulled the page view ID and the previous view time. You can see I've now sorted the table so A and B are separate, so you can see B, when you do the lag, gives a null because there's no other rows for B. So the next thing we want to do is we're going to get the page view ID of the first page of the new session. So we want to know when we started a new session. There's 3 sessions here. The first session for A starts, there's no previous page view, so that's a new session by default. At 10:51, A's previous page view was 10:15, so again, no previous session. And finally, for B, they only have 1 session, so again, it's a new session by default. So how do we get that function? So here, we're doing a case when. We're saying when view time is null of the previous page, so it's keeping our lag and lead, then we want it to be a new session, so we're going to return 1. If the date-time difference is less than 30 minutes, then it's not a new session, so we return 0. Otherwise, we return 1. So that's our flag for a new session. So this now gives us 1 when there's a new session and 0 otherwise. So the next thing we want to do is count which session we are in for this user on this day. I've not put date in, but if you're doing this in real life, you'd probably want to do this by day. So here, session 1 for user 1, then session 2, and then session 1 for user B. So apologies for people sitting at the back who probably can't see this. I've got a learning on moving code up. But what we're doing here is a different window function. We're partitioning by user ID, we're ordering by view time, and we're doing rows between unbounded preceding and current row. From what we've done so far, you know about everything apart from unbounded preceding. So I'll talk through this code. We're saying partition by user ID, so again, splitting for each user into its own row. Then ordering by view time, so sorting those for each user by view time. And then we want to say rows between unbounded preceding and current row. You'll remember from moving examples, we said 3 rows preceding, 4 rows preceding. This is like the extreme version of that. So this is summing everything up until now. So it's effectively a cumulative sum. And then we're summing that for new sessions. So this gives us this out. The reason this works is the first row, we're summing this row, everything above it, we've got 1. The next row, we're summing this row and everything above it, so it's 0 plus 1, so it's still 1. Similarly for the third row. On the fourth row, we've got another 1, so we're then summing it and we've got 2. And that's how that works. Finally, we want to get a unique session ID for that, which allows us to do some analysis. The code for this is similar to what we had, so what we have here is what we had before. And all we've done here is added the user ID. We're doing some string joins, so we're joining user ID as a string, joining the text space dash space, and then joining the same function we had above. And that gives us a unique ID for that user for that day. So yeah, we're now done. We've got our page view ID, our user ID, the page they visited, the view time, and the unique session ID of that page. This means we can do analysis now. So you might want to count the number of sessions. So there you just need to count distinctive session ID. You might want to calculate the length of the session. So you can subtract the min and max view time from each other for each session ID. Or you can count the number of page views. So find, like, for example, one-page sessions or something like that. So here you're just using a having count equals 1. Perfect. That's everything I have for you today. Thank you very much. I think we've got a few minutes for questions.
Great. Thanks, Lydia. Lots of people in here, so I suspect lots of questions. We've got a few minutes before the next talk, so who would like to start? Right, it would be all at the back.
To make your life easy.
Hi, about the time series procedure that you have done there, especially the moving average, 6 preceding, 1 follow. Is there any rule of thumb when to choose 6 and 1, when to choose 2 and 3, and so on, or it doesn't matter because?
So the way I'd think about this is what's the noisiness in your data from? So a lot of businesses will have either a weekly or a monthly pattern. Yeah. So a lot of retail businesses, for example, will be weekly. If you want to average that out, a 7-day average or a multiple of 7 is a really good idea. If you've got a monthly pattern, you might want to do a multiple of, say, 30 or 31, a little bit more complicated.
So if this is weekly, for example, and you start from the session 1, then you do 1 preceding the second you do 1 preceding 6 following, or?
You always do 6 preceding. Yeah. Oh, you mean whether you do 6 preceding or whether you do?
1, 2, 3, 1, 6, 6, 1.
So I'd use 6 for a weekly because you're averaging over the last 7. And I'd always do it lagging, but you can think about whether you want it to be the average going forward or backwards. Yeah.
Hi. So in terms of the repetition of the ID, is that not a design issue as opposed to a post-design issue? Because you can auto-increment.
Oh, you mean in product detail? Yeah. It is definitely a design issue. So it's kind of why I talked about, where are we? Probably shouldn't try and go backwards to there. But yeah, it's why I talked about this thing, because in general, there should be, if you're lucky enough to have a great engineering team, data engineering team, which not all of us are, you should have someone who's thinking about this and saying, like, okay, either product ID needs to be unique or product ID in active row, if active row equals true, needs to be unique, something like that. So yeah, there should be someone checking that, but in my experience, there isn't always. And so that's sort of the motivation for my example.
Thanks for a great presentation. I had a question in terms of avoiding errors, like kind of logical errors in the SQL syntax. So how would you think about that in terms of like structuring the order of joins? Say if you're joining by user ID plus something else, to have that like left table to right table throughout, or in terms of even the tools that we would use, like IDEs, auto-completing, kind of prettifying syntax. Are there any kind of suggestions or best practices you would have there?
Yeah, so there's 2 things I always think about. The first is because I made a really bad mistake and did an accidental cross-join once, of like when you're joining onto a table, you always want to have a standard way round. You put the ID from that table. Because it turns out even if you do an inner join, if I'd got a third table here and I just had the same on clause again, it would actually do a cross-join and it would just return all of them. So making sure you always have it first or you always have it second can be a really good approach. Yeah, otherwise with joins, the other thing I usually do is do all my inner joins first and then my outer joins, because otherwise it can be a little bit confusing of like, are you only getting the inner join row if the outer join is true, things like that. So making sure that's really clear. Those are probably the two that come to me right off the top of my head, but I think there's definitely more. So we can chat afterwards if you want to. I'm around till 6 o'clock.
Hello there. So for a data analytics person, would you recommend rather studying SQL or Python?
In general, SQL. I'd say everyone who does data analytics should know SQL. And then Python is like, it's some jobs it's a plus, some jobs it's essential, but SQL is kind of the core, the way of accessing and manipulating data in most cases, especially if you've got large data sets.
There was a moment you mentioned efficiency of query when there was an inequality. Is there a way you recommend analysts can learn about how to make their queries more efficient? Or is there like a test they can do, or are there resources you'd recommend?
So, yeah, it's a great question. Almost all versions, so the reason this is complicated is different versions of SQL compute things differently. So actually in the back end, how they do the code and how they run the code differs. So in some versions, some people say put the smaller table first and it's quicker, but that's not true for all of them. So the first thing is you can use explain plans. So there's a function in I think all versions of SQL which basically tells you how that version of SQL is going to run your code. They are relatively impenetrable to understand, but there's ways of like Googling them and how they work. One of the examples here I actually just Googled to see which was faster because I didn't know. So that if it's something that's a really simple trade-off, you can do that. But usually the explain plan is the way to go.
Hello, thank you.
Nice.
Firstly, thank you for the presentation. I have a question about computational complexity with regards to window functions. So, first couple of examples that you showed, maybe the first one, you showed a subquery using a with statement. So, in terms of computational complexity, so how much would a window function sort of reduce it compared to having a subquery?
Yeah, that's actually a really good question. Let me just find that. So this first one, yeah, I actually Googled this. So this is this link down here. So this first example, it sped it up by about 2/3 from the test that someone did. This was one guy testing on the internet, so take it with a pinch of salt, but it seemed to speed it up about 2/3 versus the version with the subquery. This one, the longer example where we had to do the less than, that's effectively a cross join, so that's just incredibly inefficient. So that one's probably much, I didn't Google it, but I guess it's 10 times worse or something like that.
Okay, I think we're going to have to swap over for our final speaker. So let's thank Lydia again.
Perfect. Thank you very much.